So in summary, for the P series, if P is between 0 and 1, including 1, the P series diverges. If P is greater than 1, then the P series converges. So here are some examples. The P series 1 divided by n to the 1 half. This is a P series with P equal to 1 half. Since 1 half is between 0 and 1, the series diverges. This is a P series with P equal to 0.2. Since 0.2 is between 0 and 1, this series diverges. The harmonic series, which is the same as 1 over n to the first, is also a P series with P equal to 1. Since P is between 0 and 1, including 1, the series diverges. The series 1 divided by n squared is a P series with P equal to 2. Since P is greater than 1, the series 1 divided by n squared converges. The series 1 dividing by n to the 1.52 is a P series with P equal to 1.52, which is greater than 1. And therefore this series right here converges. Here we have the series 1 dividing by the square root of n to the third. The square root of n to the third is the same as n to the 3 halves. So the exponent 3, the root number 2. So 3 divided by 2 is a P series with P equal to 3 halves, but 3 halves is greater than 1, and therefore this series converges. The series 1 dividing by the third root of n to the fifth, which is the same as n with exponent 5 dividing by 3. 5/3 is greater than 1, and therefore the series converges. And now let's look at this example. And we want to use the P-series test to show that this series right here converges. This series is the same as, it has 1 dividing by the third root of n to the fourth plus 1 over n to the third. Then we can rewrite it like this. Summation of sum is sum of summations. So summation of a sum is the sum of two summations. This is the third root of n to the fourth. Then if we rewrite it using rational exponent, then it'd be n to the 4/3. This is a P series with P of 4/3. Thirds. which is greater than 1. And therefore, this series converges to some real number, we'll just call it S. And then this series right here is a P series with P equal to 3, which is greater than 1. And therefore, this series converges to some real number, and we'll call it T or something. So this series converges, and so this series right here is equal to S plus T converges. And now let's look at an example where it doesn't converge. So we have the series of 1 divided by the third root of n to the 7 plus 1 over n. This is the summation of a sum, so we can write it as sum of summations. So this is summation of this sum, and it becomes the sum of two summations. This series, this expression right here, we can rewrite it using rational exponent, and so we have exponent 7/3. And so this series right here is a P series with P equal to 7/3, which is greater than 1. This series right here converges to some real number S. Now, with this series right here, this is it's also a P series with P equal to 1. And we also know that it's the harmonic series. And this series diverges to infinity. And so we come back right here. This series converges to some finite number s, and then the harmonic series converges to infinity. So this is a real number plus infinity, it's just infinity. And therefore, this series right here diverges.